All right, let's jump right in. We're about to connect two things that sound like they have absolutely nothing to do with each other: a government policy document in Uganda and a planetary scale computer. It's a wild story about how fixing a local problem can spark a global solution. But first, we have to start with the problem, and it really all comes down to this number. See, back in 2007, Uganda had this big plan to build 22 industrial parks to kickstart its economy. Fast forward to 2024, and only 3 of them were actually up and running. I mean, that's a staggering failure rate, and it tells you the system itself was just fundamentally broken. So that's the big question, right? When the old model is so clearly failing, when your plans just aren't happening, what do you do? Do you try to patch it up? Or do you have to be brave enough to just tear up the old plans and start over with a completely new set of rules? And here's where it gets really interesting. For Uganda, the answer started with, yes, a new rulebook. But the crazy part is where that rulebook eventually leads. It ends with a distributed, intelligent network that spans the entire globe. Okay, so to really appreciate how revolutionary this new solution is, we have to understand just how deep the old problems were. Let's take a quick look at why that original strategy for industrial parks just completely fell apart. It was really just a cascade of failures, one thing knocking over the next. Get this, only 13% of the investors who were given land actually built anything. And why? Well, there was no coordination for basic stuff like power and water. The tax policies were all over the place. The whole thing was so dysfunctional that for years, the manufacturing sector's contribution to the economy just flatlined. It was a total system failure. So, faced with this mess, the government, with some help from groups like UNITO, decided enough is enough. They didn't just write a memo, they threw out the entire playbook and wrote a brand new one from scratch, changing the whole idea of what an industrial park could even be. And at the heart of this new playbook is the Eco-Industrial Park, or EIP. Now, don't think of this as just a bunch of factories on some land. Think of it more like a collaborative ecosystem. The goal isn't just about each company making a profit. It's about everyone sharing the benefits: economic, social, and environmental. And a key to making that happen is something called industrial symbiosis. And this is where it gets really clever. Industrial symbiosis is basically the old saying, one person's trash is another person's treasure. But for industry, the waste heat from one factory could be piped over to warm a greenhouse next door. Scraps from an agricultural plant could be used to create energy. It's all about creating a closed-loop system where nothing is wasted. Now, to make sure this actually works, the new rulebook got rid of the old casual approach. Now, if you want to build one of these parks, you have to submit a super rigorous business case. You have to prove there's a market, show your tech is solid, map out all the risks, and, this is huge, do a full social and environmental impact study. It's a total shift from wishful thinking to fact-based development. Okay, so you've got this shiny new rulebook, but a rulebook is just paper until someone actually uses it. So who was the first to step up? Well, let's look at the very first test case, a project called Plasma in Uganda's remote Kabong region. And this right here is the crucial part. The partners on the project didn't just promise they'd follow the new rules. They put it in writing. This is a legally binding part of their contract. It says they must design and operate the project according to the new EIP framework, creating what they call a green special economic zone. And this is where the story takes a huge turn, because this commitment to a new way of doing things wasn't just about building a better park. See, this project in Kabong was never, ever intended to be a standalone thing. From day one, it was designed to be a single piece of a much, much bigger puzzle. All right, so now it's time to pull the camera back, way back. We're zooming out from this one project in Uganda to the massive global network that it's designed to plug into. A strategy called Operation Octagon. So what if this industrial park wasn't just a park at all? What if it was more like a nerve ending? Just one small part of a vast planetary nervous system that could sense, learn, and react to things happening all over the world, all in real time. And here it is. This is Operation Octagon. It's an 8-node mesh. You can see Kabong in Uganda is actually home to 2 different nodes, the Welcome Mat and the Crown Jewel. But look at the others. You've got the Brain up in Canada, which designs the AI. And crucially for our story, you've got the simulator down in Quartzsite, Arizona. So how do all these different places talk to each other? They use a really smart system called federated learning.
Think of it this way. Instead of sending all your sensitive, raw data from Arizona to a central computer, you just send the lessons you learned. So if hardware in Arizona is overheating, the system learns from that. And that knowledge, that recipe for improvement, is sent to its twin in Uganda instantly. The model gets smarter, but the local data stays safe and sovereign.
To really wrap your head around how this planetary computer actually works, we need to zoom in on that critical link, the special relationship between the industrial park in Uganda and its digital twin out in the Arizona desert. So here's how this twinning actually works. Kabong is the main event, the crown jewel, but it's really remote and hard to get to. So before you ship millions of dollars of expensive hardware out there, you send it to the simulator in Quartzsite, Arizona first. Why? Because the scorching hot Sonoran Desert, with its 115-degree-plus temperatures, is a perfect environmental match for Kabong. If the tech can survive Arizona, it gets certified as tough enough for Uganda. It's a genius way to de-risk the entire project. And get this, the Arizona node isn't just a test lab, it's a real, profitable business that proves the whole model works. For instance, it runs an autonomous, non-emergency medical transport service. A traditional service with a human driver might have a 50% profit margin. Pretty good. But the autonomous system, running on this sovereign infrastructure, it hits an incredible 81% margin. This is the proof that this economic engine can be picked up and deployed to other nodes. So let's bring this all the way back home. We started with a broken policy in Uganda. We saw how a new rulebook created a project that became part of a global self-learning network. So what does the future for that actual project on the ground look like? Well, its growth is planned out like a giant sequoia tree. It starts small, in a seedling phase, with just a little 150-kilowatt solar array to get the site powered up. Then it becomes a sapling, with a 1-megawatt bridge power plant. The real growth spurt comes when it launches its own compute core and starts generating revenue from AI services. And then, by year 5, it becomes a titan, a full-on 10-megawatt power plant that anchors the entire industrial ecosystem. And that leaves us with one final big question. We just watched a local policy in Uganda literally plug into a piece of a planetary computer. Is this the future of how we build things? Not just with concrete and steel, but with distributed, intelligent, self-learning systems that can connect the most remote places on Earth to help us solve our biggest, most complex problems together.